Welcome everybody, we've been given this question, integral -1 to log of 1 negative x, of course square root is there, followed by positive root of 1 positive x times dx. Now, if we were to replace x by negative x, the function would not change. So because of that fact, I'm going to rewrite this as integral 0 to 1 log of root of 1 negative x positive root of 1 positive x times the dx. Of course we need to have this 2 here. Okay, so on the left you have I. I'm going to bring this 2 down, so you have I over 2 is equal to integral 0 to 1 log root of 1 negative x positive root of 1 positive x times dx. Now I'm going to utilize the Liet rule. I will take u to be as log of root of 1 negative x positive root of 1 positive x and dv to be equal to dx. So when I integrate this, I get v is equal to x. I differentiate this, I get 1 over root of 1 negative x positive root of 1 positive x. I differentiate the first quantity. This is actually, when we talk about root of 1 negative x, it's 1 negative x raised to the power of 1 over 2. So when we differentiate this, is going to be 1 over 2, 1 negative x raised to the power of 1 over 2 negative 1. That's going to be negative 1 over 2. Times the differentiation of x is going to be negative 1. So this is going to be negative 1 over 2 times the root of 1 negative x. This is for the first part. Negative 1 over 2 times the root of 1 negative x. For the second part, also you will get positive 1 over 2 times the root of 1 positive x. Right, so this is what you will get. Probably what you can do is, you can, okay, so this is going to be our du. So now, we need to apply it in the formula uv negative integral v du. So my u is log of root of 1 negative x positive root of 1 positive x uv, and my v is over here x. So I can place it as a product like this. And this has the limits going from 0 to 1, followed by negative integral v du. V is x and my du is this entire quantity, so I'm going to rewrite it as 1 over, in fact we can take okay, let's see how it looks like. So it's going to be 1 over 2, 1 positive, or I would say 1 over 2 times the root of 1 positive x, negative 1 over 2 times the root of 1 negative x. Okay, this is in the numerator, this is divided by root of 1 negative x positive root of 1 positive x. So this is how the form looks like. Okay, so of course we need to have dx. Now I apply the upper limit for this quantity. That's good. This is going to be 0, but this is going to be root of 1 positive 1. That's going to be 2 there. And when we apply the lower limit, everything becomes 0. So over here I over 2 is equal to log of root 2. So this is what I have, followed by, we need to simplify this. So I'm going to take 1 over 2 out and then have the LCM as root of 1 positive x times the root of 1 negative x. So over here I will get root of 1 negative x, over here I get root of 1 positive x. Okay, so this is what we have in the numerator. Okay, so now this is actually, if you were to flip this, this will come to the denominator. So you have dx over root of 1 negative x positive root of 1 positive x. Now I can further rewrite this as, of course I'll start it from here, log of root of 2 negative 1 over 2 times integral, I'm going to club it like this, root of 1 negative x negative root of 1 positive x divided by root of 1 negative x positive root of 1 positive x times, of course we have x here, that x has to be present here, so it's going to be x over. Now root of 1 positive x times 1 negative x, that can be rewritten as 1 negative x squared times dx. So now we need to perform some rationalizations. Okay, so let me move to the next side. Okay, so I have to rewrite it. It's going to be log of root of 2 negative 1 over 2 integral root of 1 negative x positive root of 1 positive x divided by, this is negative because you have negative here, root of 1 negative x 1 positive x, and you have positive x times the root of 1 negative x squared times the dx. This is what you have. So this is log root of 2 negative 1 over 2. I'm going to get rid of this denominator, root of 1 negative x positive root of 1 positive x. I'm going to multiply it by root of 1 negative x negative 1 positive x root of 1 negative x negative root of 1 positive x times x over root of 1 negative x squared times dx, and this is root of 1 negative x negative root of 1 positive x. Okay, this is what we have. Now this is equal to log root of 2 negative 1 over 2. You hit these two together, so this is going to be root of 1 negative x negative root of 1 positive x the whole squared. You hit these two together, you get 1 negative x followed by negative 1 positive x, isn't it? Is a plus b times a negative b times x times the root of 1 negative x squared times the dx. So this is log root of 2 negative 1 over 2 integral denominator, you get negative 1 positive, and these two ones go away. You have negative x, it's going to be negative 2x, and you have x here, so root of 1 negative x squared. You square this, you get 1 negative x and 1 positive x, and then you have a negative 2 times root of 1 positive x 1 negative x. That's going to be 2 times root of 1 negative x squared times dx. So x and x gets cancelled. I'm looking if we can. Okay, so negative x positive x goes up, 1 positive 1, you get 2 negative 2 times the root of 1 negative x squared. Okay, so this is what we have divided by root of 1 negative x squared times dx. So I can take 2 out, and I can rewrite this as 1 over root of 1 negative x squared followed by negative, since I've taken 2 out, so this is going to be 1, right, integral 1 into dx. Okay, this is how it looks presently. So you have a dx there. So this is going to be log root 2. Of course, we have to get that integration 0 to 1, 0 to 1, 0 to 1, 0 to 1. So integration has got no change, 0 to 1. Now this one is going to be sine inverse of x, right? This component, because I have a 2 here, I'm looking if we are having any additional terms anywhere. Now one more small append here. Actually, this 2 is actually the denominator, right? And this is also the denominator. So we don't need to cancel these. These don't get cancelled. So you still have 2 to 1 over 4. And just that this becomes positive. Of course, this becomes positive. So 1 over 4 comes out. And this is going to be 1 over 2 now. Okay, 1 over 2 integral dx over root of 1 negative x squared, followed by 1 over 2 integral dx. The limits are 0 to 1, 0 to 1. So that is what we have now. So this is nothing but this is the form dx over root of 1 negative a squared negative x squared, right? So we can utilize the sine inverse formula. So this is going to be log root of 2 positive 1 over 2 sine inverse of x over a. It's going to be x, just x over a is 1 here. So followed by the limits 0 to 1, and this is going to be 1 over 2 x, the limits are 0 to 1. Limits, this is going to be log root of 2 positive 1 over 2 sine inverse of 1 negative sine inverse of 0 negative 1 over 2 or 1 minus 0, which is nothing but log root of 2 positive 1 over 2 sine inverse of 1 is going to be pi over 2. This is going to be 0 followed by negative 1 over 2. I can rewrite this as log root of 2 positive pi over 4 negative 1 over 2. On the left, it's going to be I over 2. I can rewrite this as log 2 raised to the power of 1 over 2 positive pi over 4 negative 1 over 2, which is going to be, since we know that log a raised to the power of b is b times log a, so this can be rewritten as 1 over 2 log 2 positive pi over 4 negative 1 over 2. So I need I, you cross multiply the 2, you get log 2 positive pi over 2 negative 1. So that's the solution for this question. Please like, share and subscribe.